Okay, now that we've worked a little bit with the fundamental counting principle, we're going to move on to something new. We're going to talk about permutations and combinations. Got that in there. All right. So we need to remember two things. One, when we work with permutations, we always need to remember order matters. Right? So when I like to think of permutations, I think about like a phone number or a password, right? So examples, phone number, or like a computer password, right? So we know that whatever order we put something in, it's gonna need to be in that specific order. Like a phone number, everybody's phone number is different. It matters what order it goes in, right? In a combination, order does not matter, right? So an example of this would be like just kind of dealing out cards, like a deck of cards. You know that it doesn't matter which order they go in as long as they get dealt out, right? Or like when you're in a running race and you know that it doesn't matter what order the top 10 get in as long as you're in that top 10, right? You're choosing those 10, right? There's no rank for that. So now let's look at an example of permutations and combinations. So there are 10 people competing in a contest, and let's say, okay, there are 10 people, right? And there are 3 prizes of $20, $10, and $5, right? Those are the 3 prizes. So this shows that there is an order. We need that to put things in order here to show which prizes people would get, right? They're not all the same prizes, so you know that you can't just put them in there. So this would be a permutation because order matters here, right? So we have 3 prizes. Prize 1, if we want to draw a line, 1, 2, 3. So this would be the $20 prize right here, right? This would be the $10 prize. This would be a $5 prize, right? So if order matters here, we know that there are 10 people, right? So 10 people have the possibility of winning the $20 prize, right? So once we do this, we know this is very similar to the counting principle of where we list out 10 people, and then after that, each of those have a chance of having 9, right? Of the 9 people being in the next one. So that means once we have 10 for the first prize, we know that only 9 people have the chance of winning the second prize, right? Because somebody has already won the first prize. And the same thing goes for the third prize, because once the first 2 prizes have been awarded, we know that only 8 people are left to have a chance to win the third prize. And when we multiply this out, we know that we're going to get 10 times 9 times 8, which is going to give us 720 permutations of this example. Now let's look at this with, so this is example 1, right? So now let's look at this where we're working with this with combinations. So now we have 10 people with 3 $10 prizes, right? So now order does not matter. So now this becomes a combination. Now it's going to be very similar to where we have $10 prize here, $10 prize here, $10 prize here. So we know that if we have 10 for the first one, and then that leaves us with 9 for the second one, and then 8 for the third one, this is also going to give us 720, but we need to take out where things kind of where repetition occurred, right? So now, if we look at, if we were to, so we know that we're taking 10 people, right? And we're choosing 3, right? We're taking 3, right? We're taking 3. We know that, let's just look at person 10, person 9, and person 8. We want to see about how many ways we can write this where the order would matter, right? Where we can rearrange everything. So here's 1. This is 1. 2 would be 10, 8, 9. 3 would be 9, 8, 10. 4 would be 9, 10, 8. 5 would be 8, 10, 9. 6 would be 8, 9, 10, right? So here are the 6 possibilities, right? So there's 6 ways of writing 10, 9, 8 in a different order, right? So we counted all those orders in the 720. These are 6 possibilities of the 720 that we could have gotten. So what we need to do now is take away those. So we have those 6 possibilities, right? We want to do 720 divided by those 6 possibilities, right? And that's going to give us 120 combinations for 3 people if they all had the same prize of $10. Let's look at another example here. So we have 6 people, right? So A, B, C, D, E, F, right? And we know that there's a committee of people that we're looking for 3 people, 3 chairs, right, for the committee. So we're going to do the same thing. We have chair 1, CH1, chair 2, and then chair 3, right? And we know that there are 6 people here. 1, 2, 3, 4, 5, 6, right? So if we were to do 6 people for the first one, this would be a permutation, right? Because there's 3 different chairs. And order does matter how we put this, right? So they're labeled chair 1, chair 2, and chair 3. So we know that this would be a permutation because order does matter. Now, once we have 6 people here, we know that there can only be 5 left to choose for the second chair. And then that leaves us with 4 for the last chair, just like before, where order does matter. And we need to make sure that we're counting correctly here. So that would leave us with 6 times 5 times 4, which would give us 120 permutations. Now we look at another example of this where we would be doing a combination. So we have the same thing, right? A, B, C, D, E, F. And now we just have 3 chairs, not in any order. So chair, chair, chair. So this is a combination. And we need to remember here that we have the exact same thing as before. So we have 6 possibilities for the first one, times 5 for the second, times 4 for the third. But with this, we have to be careful because we have 6 people, right? And we're taking 3. We're choosing the 3. So what we need to do here now, let's say that we choose D, E, F. How many different ways are there to write D, E, F? Here's 1. 2 would be D, F, E. 3 would be F, D, E. 4 would be F, E, D. 5 would be E, D, F. 6 would be E, F, D. So there, just like before, we have 6 ways to write this out, right? We have 6 ways to rearrange D, E, F. So now, 6 ways to arrange D, E, F. So now we need to take these away from the original 120. This is 120, right? So then 120 divided by 6 is going to give you 20 combinations of these for the chair.